function is defined by f of x is equal to the modulus of x plus 2 for all x values. And the modulus means that all the answers for the y coordinates on this curve have to be positive. Start off by drawing the graph of y equals x plus 2. And we've just to consider values of x between -3 and +3. So we'll draw a set of axes and also we'll put dotted lines from -3 to +3. Y equals x plus 2 is the equation of a straight line. Gradient, the number in front of the x is a 1, so the gradient is 1, and the y-intercept is 0, 2. So this line is going to pass through the points -2, 0 and 0, 2. So there's the line y is equal to x plus 2. We want to modulate this. We want to now find the modulus of x plus 2. The places in the graph which have got y, positive y coordinates will remain as they are. So this part of the graph will not change, since these are all positive y coordinates. This part of the graph has got negative y coordinates. When we find the modulus of them, it will just give us the equivalent positive coordinates. So this will have the effect of reflecting this part of the graph in the x-axis. So our graph will look like this. This will be the point -3, 1, since the original graph it was -3, -1. This point here will be the point 3, 5. So this is the graph of f of x equals the modulus of x plus 2. In part B, we're asked to draw on a separate diagram the graph of f dash x. Now f dash x means the derivative or the gradient of the tangent for each value of x. So we'll start off by drawing a set of axes and looking at this first bit of the graph. This part of the graph, f dash x, will be -1, since the gradient of this line is -1 for values between -3 and -2. So this part of the graph, f dash x, is -1. After that, from 2 right up to 3, after that, from -2 up to 3, the gradient of this line is 1. So f dash x is constantly 1 for values between -2 and +3. At -2, well, at -2 on the left, the gradient or f dash would be -1, and on the right of -2, f dash x would be +1, which means that f is not differentiable at -2. So at -2, f dash x is not defined. So to draw the graph of f dash x, first of all we'll draw the values between -3 and -2. F dash x is constant, it's -1. At -2, I'll draw an open circle, since f is not differentiable there. After -2 all the way up to 3, f dash x is then equal to +1. Remembering at -2 it's not defined, so I'll put an open circle there and then a straight line thereafter. This is the point -3, -1, and this is the point 3, 1. And this is the graph of f dash x for values of x between -3 and +3. We have to use the substitution x equals 4 sine theta to evaluate this integral. So if we call it I is equal to the integral from 0 to 2 of the square root of 16 minus x squared dx. So x is equal to 4 sine theta. Differentiating dx by d theta, but we'll write this as dx equals 4 cos theta d theta. Now the limits at present are 0, 2. We want the limits in terms of theta. So if x is 0, that means that 4 sine theta equals 0, and 4 sine 0 gives 0, so theta is also equal to 0. When x equals 2, the upper limit, 4 sine theta is equal to 2. So sine theta is 2 over 4, which is a half. Sine theta is equal to a half. The angle whose sine is a half is pi by 6, so theta is equal to pi by 6. And this is our upper limit. So we've got our new limits. Our next thing is to now substitute for the x and for the dx. So we're going to have the square root of 16 minus, instead of x squared, we're going to have 16 sine squared theta. The dx is 4 cos theta d theta. So we times this by 4 cos theta d theta. There's a common factor of 16 inside the square root sign. We can take this 16 outside a set of brackets, and that will be 16 bracket 1 minus sine squared theta. We can then separate into two square roots. The square root of 16 times the square root of 1 minus sine squared theta times 4 cos theta d theta. Now we know that 1 minus sine squared is cos squared theta. So we can replace this by cos squared theta. Root 16 is 4. So the integral is 4 times the square root of cos squared theta times 4 cos theta d theta. Square root of cos squared theta is just cos theta. So this is just 4 times 4, 16 times cos theta times cos theta, 16 cos squared theta d theta. Now, as this stands, we can't integrate. We can't integrate powers of cos or sine. We have to substitute for formulas with double angles. Cos squared theta is a half bracket 1 plus cos 2 theta. So if we now replace the cos squared theta by a half bracket 1 plus cos 2 theta, that will give us a double angle which we will be able to integrate. So 16 times cos squared theta, which is a half bracket 1 plus cos 2 theta d theta. 16 times a half is 8. So this is the integral of 0 to pi by 6 of 8 bracket 1 plus cos 2 theta d theta. We can now integrate. 8 times 1 is 8, integrated is 8 theta. Then 8 times cos 2 theta, 8 cos 2 theta, integrated is 8 sin 2 theta over 2. 8 theta, 8 over 2 is 4, so that's 4 sin 2 theta. Putting in our limits from 0 to pi by 6. We now have two brackets separated by a minus. Into our first bracket we're going to put theta is equal to pi by 6. So 8 times pi by 6, or 8 pi by 6, plus 4 times the sine of 2 times pi by 6. 2 times pi by 6 is pi by 3. Minus in the second bracket, well, they're both going to be 0. 8 times 0 is 0. 4 times the sine of 0, sine 0 is 0, so that's also 0. 8 pi by 6, we can cancel a 2 into each of them, which gives 4 pi by 3. And sine pi by 3 is root 3 over 2, so that's plus 4 root 3 over 2. We could take a common factor of 4 outside a set of brackets, and we would have pi by 3 plus root 3 over 2 inside the bracket. And this is the answer to our integral. So we're trying to find a cubed in the form k times I. We're told that a plus a inverse is equal to I. Now, if we try and get a squared first of all, if we multiply both sides of this equation on the left by a, then a times brackets a plus a inverse is equal to a times I. Multiplying out the brackets, a times a is a squared plus a times a inverse. A times I is just a. A times a inverse, well, that's just the identity I. So this gives us that a squared plus I is equal to a. If we rearrange this, we can get that a squared is equal to a minus I. And we'll call that equation 1, since we'll use it later on. To get a cubed now, if we multiply on the left both sides of this equation by a times a squared is equal to a bracket a minus I. The a times the a squared is a cubed. Multiplying out the brackets, a times a is a squared, and then a times I. From earlier, equation 1, a squared was a minus I, and ai is just a. This means that a cubed is equal to a minus I minus a. And the a's will cancel, just leaving us with a cubed is equal to minus I. So we've been able to write that a cubed is minus 1 times I. A cubed is equal to k times I, where k is equal to negative 1.